So we'll begin now. Uh, Whatever that we have done in the last class, we'll continue further. In the last class, we have gone through the various software development process models like a waterfall model, iterative model. Within that, we have seen the incremental model, spiral model, like this prototyping and all that things we have seen it. So now we'll begin with the socio-technical systems, right? Textbook version of this that we will get into, right? When we talk about the system, I have shown you the video in the first class also. The system is made up of several components. They work together. Okay, they interact with each other. They cooperate with each other. I mean, they are correlated. Okay, this one. They send a message among them. Right. Finally, it makes to work. So this textbook speaks about that system is a purposeful collection of interrelated components that work together to achieve some objective. True, right? Several objects together, okay, will give a service we call a component. A component as a service. Then several components put together, it becomes subsystem, right? Maybe a student registration system. Then several subsystem together makes a system. That's what we are seeing through the video also, right? With this background of whatever that we have done before about the system, its collection, its interrelated components, right? Purposeful collection, right? All these terms that already we have gone through. Now let's look into the other aspect of what textbook speaks about, right? So it speaks about system engineering. This also we have introduced. System engineering process, when you look into that, your requirement collection, your design and all, you need to develop a subsystem development, you have to, then you have to integration you have to do, installation you have to do, right? Whatever you are done, you have to install it. And system will undergo changes modification. I told you about the corrective maintenance, adaptive maintenance. Under that it gets into, okay. Then I told you about system decommissioning. It is being withdrawn from its functioning, right? A new system will get into this all, okay. The phases of any life, even human being, we people, right? We take a birth, okay, we study higher school, okay, college, we work and all. Finally a day will come and we need to die. That's called decommissioning, right? Is equivalent to that. So that's a theoretical aspect of that. We'll deal with that in detail whenever, whatever that is required, okay, later. Right. Now, when you look at the different discipline, when you talk about the system is not only the program. Software, okay, when you talk, it is a program. Okay, system, okay, when we talk about that, it's a collection of hardware from different branch of engineering, right? So you may need a sensors, you need actuators, you need okay, sensors and all, and interpretation, computation, cloud related things. People talk about that. It is a software engineering, electronics engineering, electrical engineering, all the things, okay, makes the discipline, right, of system engineering, right? It is not that. So when you work later, you don't think that one, you don't need a mechanical engineering, you don't need electronics engineering. That's why the open electives have been put into that, right? You can take any other electives offered by other department also, because you can widen your system engineering perspective of knowledge. Okay, that's what is required. See, tomorrow if at all you have been asked to, okay, develop a software required for civil engineering and all, remote sensing, or it could be surveying related things, or it could be structural engineering related things, you need to know about that, right? That's what is an outcome of any engineering education, right? So, but please be good in your programming, design, right? Testing, right? Network, database, algorithms, data structures, programming, right? That will enable you to, okay, do better in other disciplines. System design process, when you look at that, you have a requirement. Okay, you have a subsystem, you need to identify what makes my system, right? In the video I've shown you about the four-wheeler, okay, Honda vehicle, right? It has several subsystems, maybe ignition system, maybe braking as a system, okay, maybe engine, right? Maybe petrol tank, that is another system. Sensors are other system, automated system in that. So all that subsystems you need to visualize, right? Then requirements can be collected properly, right? And your requirement you have to partition based on subsystems also, right? Then you need to identify the functionality of the subsystem, right? And define the interface. Today morning in a session, you are seeing interfaces, okay? Interfaces at subsystem level, interfaces at, okay, component level, interfaces at, right, object level. Interface is not a Java interface I'm talking. That the object, how do it interact with outside world is called interface. A component, how does it interact with outside world? Right? A subsystem, how does it interact with the outside world? A system, how does it interact with the outside world? Okay, there's GUI. Graphical user interface is the one which through which the outside world interact with the internal systems. Got it? That's okay. This is about the system design process, right? Theoretical stuff. If somebody said a question theoretical, probably from the textbook, these things may come for few marks and all. I'm giving my flavor of practices, and this is a theoretical flavor, right? You have to prepare for all by textbook, right? And go through every line, every keyword in that capture, every diagram given in the textbook you capture, right? We don't know who is going to set a question paper. Maybe outside the institution, if they set and they go by textbook version, then things you should be ready for that. Right. Now we talk about the architecture. Today's topic is about the architecture. So when you visualize the system, okay, you need to build a diagram showing several component, several partitions, several subsystems which are independent, yet they interact with each other, their behavior, their interaction and all. Try to visualize in one simple diagram. Got it? The simple example is for the house construction, okay, you have a blueprint approved by municipal corporation, right? There it speaks that this is a kitchen, this is a bathroom, this is a bedroom, this is a living, okay, this is a hall, this is the sit out, this is a outhouse, this is a storeroom, this is a puja graha. They define all these things, they connect with each other, they assign certain responsibility for that, and each one is independent of each other. But yet they connected with each other, and the whole the house can be visualized. Similarly, okay, can you do it for the system which you are developing it? Right? So architecture speaks about different partitions of the system, right, which are logical part, which are independent, which are connected with each other, speaks about the behavior, their interaction, their connectivity, and all these things, right, makes an architecture. And when you represent this in civil engineering, they have got their own notations. In computer science engineering, when we talk about the architecture, we have got our own notations, right? So here is a notation. Uh, Ashish, list the different symbol used, okay, while creating an architecture, right? Please write in. I've added lot many questions today based on the topic which I'm right now covering. In class question bank, please add it. Right? List the various symbols and their meaning used in, okay, designing an architecture. Client is represented is something like a traffic symbols. Client, server, database, application, okay, bus type connectors, database access, request and reply kind of things, pipe, right? Pipe is nothing but the information flow from one component to other component, one application to other application. RPC is remote procedure calls, right? Connector, these are all connector example, component examples, right? List. But this is not the question, kind of questions that you are going to get it. I'll tell you looking into our in-class question bank. Now look into this, right? You want to show the client server architecture. Here is a client, web enabled client or otherwise. Then here is a server. Server in turn access the databases, retrieve the information from that, okay, and present it. This is very simple, right? Probably, okay, show the architecture of survey system, some theoretical, okay, questions you will get it from the book, and you will write the answer, you get 10 out of 10 and explain about that, right? That is not going to help you for the industry preparation, placement preparation. But what is going to help you? I'll tell you. Can you apply knowledge of all these symbols and given a problem, identify subsystems, components, their behavior, describe the behavior, and connect it using standard notations? Wait, my session today ends with those examples, right? Right. Now look at that architecture for the survey system with authentication. Client requests server. Server in turn authenticate that you are okay, authorized user or not, then allows you to do all your business. This is a component. All are independent. The name themselves speaks about what is the responsibility. You can have a description followed by this diagram also. Client, the role of the client is so and so. Role of the server is so and so. Role of authentication server is so and so. Database, the role of this is so and so. It stores all these things. You can have a few pages of description on this. Got it. Then look at that architecture for the survey system with a caching. A client request, you store what the client is requesting, right? You access the database, you authenticate, you access that one. Whatever that has been accessed, you store it in a cache manager. The next time client requests the same information, instead of getting into the database, you take it from the cache and provide it. That's what happens in all web-enabled applications, right? That's why in your mobile or in your laptop, you clear the cache. Are you getting it? Right? That's now what is the role of cache manager in this architecture? Look at the pipe and filter example. Oh, beautiful things. Right? What's the meaning of this? Right? Sequencer is one component. The whatever it collects, it pushes that data. There are two models. One is a push model, other one is a pull model. Whenever sequencer develops something, it simply pushes the output to the next component. Got it? Sequence of words, it will simply push that one. This is a push model. In other model, the arrow mark is reversed, right? Let me tell you about that. Let me mark it with a color, right? When I say that one, same thing. Though this is a component number 1, component number 2, component number 3, I can put the arrow mark like this. That means sequence will produce something, it will keep it in buffer. Right, sorting, whenever this component wanted something, a sequence of words, it will pull from sequencer. So this is a red color arrow mark, whatever I said, that one is a pull model, whereas right, if at all sequencer produce some words, it simply pushes that one. It doesn't wait for the sorting to ask for that. This is the push model. Ashish Nadon explained the push and pull model in pipe and filter architecture. This is a pipe and filter architecture. Filter is nothing but each component, whatever it computes, they're called filters. Pipe is the one where it facilitates flow of information. Right? Even in Unix operating system, you might have gone through cat, vertical line, you use it and send it to some other things, other command. The output of the cat, you send it word count. Cat, vertical line, right? Then you can say word count, WC, right? So cat, instead of displaying the content of a file on screen, it will direct that uh, to other command. What is this? It is again pipe and filter architecture only. Okay, don't underestimate the such simple diagram given to you. These are all very popular things that is being used. You can try it today. I think you all might have tried. Cat some content of the file, right? Instead of displaying it on the screen, you pass it to the word count, right? And check into that. The output of cat some file name is being diverted to the another command word count. You try this. What is this? Pipe and filter. What kind of things? It is a push model. Cat, whenever it is ready, content that one the sequence of words, it will push us to word count. Right? This is unnamed pipe that we use. That exercises also, right? We have gone through. Right? This. So filters are the thing, but take something, compute it, and sends it to other things. Right? Sorted word is a filtered out. Sorting is a filter. Right? Sequence is a filter. Counting is a filter. Right? You can try all these things. Hope uh, Ashish and Arpita making some sense out of the architecture, what we are talking all about. Right? Right. Now let's get into other things. Right? Send shared data, kind of an architecture. So you have a different component a subsystem developed, right, and right, all have a common repository like a global variables, but they're all controlled one, right? So that there won't be any conflict in storing and retrieval kind of things. Say, for example, registration. You do registration and get into repository. Okay, what is this? What is this repository? Okay, rectangle that we are represented. Okay, okay, what is that? Okay, rectangle. Okay, here now look at the application with the edge, right, not sharp one, rounded edge rectangle. Rounded edge rectangle is being used there. See there, right, rounded edge rectangle. It indicates that it is, right, an application. Okay, a sharp edge rectangle indicates server, right? There is a difference between these two. Probably one more question somewhere you get it. What is a notation used for application to be represented in architecture diagram? How it is different from server? It's a small thing, but this small thing will test your memory power, right? But developing such architecture diagram will help you to solve the problem. These are two different things. With memory power, if at all you get a S grade, you are of no use. With the memory power, getting S grade and then solving a problem is a real, okay, what is required, right? So registration, what is this oval? Oval represents what? Right, now look at that. Right, here oval represent a client. This is an application, right? So these clients connect with okay, application, right, for exchange of information, registration, course feedback, administrators, approvals, reports. Your admission need to be approved. Who will do that? You register, then approvals will be done later. Right? This is an application repository and act as an application. This is the shared data example for an architecture diagram. Right? Simple. Okay, alarm systems. Look into that. You have a movement sensor, you got a door sensor, you got a siren, you got a voice sensor, okay, you got telephone caller, right, and alarm controller. This is the overall architecture of a system, right? But writing this in the exam for the same question, alarm system, like getting 10 out of 10 doesn't make sense. Remember it. Then what makes sense? Wait for that. What makes sense? Wait for that. Right, then after architecture diagram, I was telling you need to describe every component of this. Okay, every component, every subsystem, right? Describe that. For example, movement sensor subsystem description detects the movements in the room monitored by a case system. No, should we write all these things? Yes, you need to write. Look at the very professional words, how it is being written. Door sensor detects a door opening in external door of the building. Alarm controller controls the operations of the system. Siren emits an audible warning when an intruder is suspected. Oh, nice, short, crisp. Right? You need to be very crisp when you prepare a report. Crisp, matlab, Parle G glucose biscuit. That's all. Right? So how nicely the things have been described. Right? Looking at that, you should be in a position to write all the reports. Now look at that, some important use of software architecture. Why do I go for this architecture? Okay, is it not? It gets me the overall view of a system at one glance, train timetable at a glance, all train in the country. Then it speaks about how they are connected. It speaks about what are the responsibilities assigned. It gives me better understanding of the system in short. This very crisp. So let's look into, right, what is that I've written. Right? The importance of software architecture is to understand and communication. You can communicate better for all your entire team members. You can reuse because there are no domain specific, okay, words have been attached. They are generic, client, server, okay, this. You can construct, okay, you can build and evolution can be done on that, and you can analyze on this. Okay, what's the use of an architecture? The architecture helps to understand better. Okay, you can communicate with your team members better, including the clients also, right? It can be reused and all. Like, it helps in analyzing the whole system, right? Better. Okay, what's the use of software architecture? Right, explain with example. No other aspect of what textbook speaks about that. Let me talk about that. See, human and organizational factor from the systems environment that affect system design. You can note down, Ashish, same thing. Take a snapshot of this, right? List and explain the various human and organizational factors from systems environment that affect system design. These are theoretical things. That's why I put a line across all these things. See, whenever you bring change in the process, whenever there is a change in the job profile, whenever there is organization change, people oppose that. Correct. Now look some of these things. Does the system requires a change to work processes in the environment? If so, training will be certainly be required. If the changes are significant or if they involve people losing their job, there is a danger that the user will resist introduction of such system. Computer automation. Whenever you do computer automation in government organization, particularly, people have a fear that we are going to lose the job and all. Sometimes it is true, sometimes it may not be, right? If at all you don't adapt to the new things, probably you are going to lose a job, right? So, okay, there is nothing like a, it is not a responsibility of a okay organization to give a 100% security, even though you are not ready to adapt to the new environment. See, all these 30 years, okay, recently in one of the government organization, very, okay, a good organization in of Karnataka state, okay, from SDM Engineering College, we gave consultancy. And they were supposed to prepare, okay, online video learning material and upload. There are a few people, officers, who were about to retire in next 6 months. But so beautifully they have prepared, okay, learning material, video recording, whatever we are doing it, and educated more than 300 plus officers whole Karnataka state, for which we are given a consultancy. Look at that officer, he's going to retire in next 6 months or a year, but yet adapted to the new environment. If you don't adapt, okay, then probably people will ask you to go out of the system. That is an order of the day. Job changes. Okay, probably people ask you are doing all these days this one right now. Okay, instead of blackboard teaching in the classroom, you do okay online. Okay, training programs. No, I don't know how to record. I don't know how to use that. You need to change that one. So designs that involve managers having to change their way of working, people have to do it. Right? Look into that. Organizational changes. Does the system change the political power structure in organization? If an organization is dependent on a complex system, those who know how to operate the system have a great deal of political power. They get okay highlighted in the organization. That they become a leader, they are become a dictator and all these things. So you need to adapt. Otherwise, you'll be okay dictated by some other set of people that could be your juniors sometimes, right? So that's what is a human and organizational factor in system design also. As system design brings certain changes, okay, in terms of right the environment, the culture, the way people look into that one. You need to get connected with these things and then design about that. There are some key points given at the end of the chapter. Please go through. Right, there are self-assessment exercise given at the end of the chapter. Please go through. But now what is that I'm going to share with you now is right our in-class okay question bank, whatever that we have put it, right? um, yeah, it is here. I've added in advance. Ashish, you can amend, do the append all these things little bit whatever we spoke about that. So when you build an architecture, right, the whatever theoretical thing I said, right, that is not a good learning. But what is good learning? I'll show you. All red mud colored one are the very interesting things which will truly make you uh, an engineer. I've added from the textbook also. Yeah, look at that. A flood warning system is to be procured which will give early warning of possible flood dangers to sites that are threatened by floods. So description. Draw a block diagram of possible architecture for such system. You should identify the principal subsystems and the links between them. So can you visualize the given scenario and draw the architecture diagram? This is the kind of questions that you should expect in the examination, right? Now look into other interesting thing, right? I'll read question number 44. A multimedia virtual museum system offering virtual experience of an ancient, the Greece, is to be developed for consortium of European museums. The system should provide user with the facility to view 3D models of an ancient, okay, the Greece through a standard web browser, and should also support and immersive virtual reality experiences. What political and organizational difficulties might arise when the system is installed in the museum that makes up a consortium? So, as a designer, as a architect, as an analyst, you need to have a look into these aspects also, right? Look at that. Another thing, what I'll say, you are an engineer involved in the development of financial systems. During installation, you discover that the system will make a significant number of people redundant. The people in the environment deny you access to essential information to complete the system installation. To what extent should you, as a system engineer, become involved in this? Is it your professional responsibility to complete the installation as contracted? Should you simply abandon the work until the procuring organization has sorted out the problem? Probably this could be one of the question in your HR round also interview. It's a common sense. It is an outcome of an experience. What is that you do? People are not sharing, giving access to essential information. What is that you do? Should you continue, or you ask the client to resolve your problems, then you get connected, or the combination of that? Here, there is nothing like a correct or wrong answer. What kind of visualization, right, you build and write the answer is very important. See, please develop. Such things will help you for your interview, right? It could be one of the HR question, could be one of the technical round if software engineering is being focused. Please remember, if this course is focused, then this kind of preparation is required. Are you getting this? Right? There are many textbook version of self-assessment exercise. I'll put it. Please go through that one. Right? Uh, Explain the pipe and filter architecture. He has written. Yeah, he has put the screenshot itself. Oh, that's nice. Add some questions there. List and explain human organizational factors and remove this later. Ashish, you are very active. Good. Right. So add a question and remove this one. List and explain various human organizational factors from the system's environment that affected the system design. That is a question. These are the answers. Process change, job change, organizational changes. Right? So this is the kind of preparations that we are doing it. Hope you all like this, right? And 1 minute. Hope you are enjoying learning. If you have any questions, I would like to answer. Otherwise, we'll stop here. Any questions? We spoke about the architecture. We spoke about the architecture, and that's the end of the first part of the things. Next week, quickly we'll get into critical system, and we will try to complete the first chapter, right? And be ready for first internal exam. Second chapter we'll get into very quickly. We are mixing all the things. Chapter number 1 and 2. Chapter number 2. Okay, when you look into that, let me share with you that also. My course now. and in that syllabus, in that software engineering, right? So when you look into that, the first overview we have completed, then critical systems will go through that. That makes the I number one, right? We have to get into requirement. Requirement engineering also we have gone through, right? Then we will get into other aspect of this. We are mixing chapter number 1 and 2, okay, which is there for I1, right? Put together, it is around 12 hours. But additional hours, whatever we are doing, that is different. In week number 1, we got 3 classes. Week number 2, we got 3 classes, 6 hours, right? Then still we have something to go, right? So under 2 weeks, we'll finish this particular thing. Please refer textbook every word in that, because if anybody set a question with a theoretical mindset, you are caught, right? Practice based and theoretical both is required for this. So we will get into critical systems from next class from Monday, right? Any questions at this stage? I'll stop sharing the screen. Any question at this stage which you wanted to ask me, I will answer to your question. Otherwise, we'll stop. There are 53 students joined. CR, take care of that one. There are many students, around 70 in the class, Google class. You'll have to join.
Yes, sir.
Any
Yes, sir.
questions? Put it in the chat box. I would like to answer. Any questions? If not, we'll stop it. Arpita and Ankit, Arpita and Ashish,
Yeah.
shall we stop here?
Yes. If
Please
there's
look
no
into
there are no questions.
theoretical aspect, bookish, book driven, and the examples whatever I shown, that is real preparation, right? And you have to study for both. Sometimes your question paper will be only theoretical. Sometimes your question paper will be only practice one. Sometimes question paper will be mixed of that. It depends on who set the question paper. Got it? So question paper, okay, randomly it will go outside the institution also, right? Be prepared for all. But for placement, both theoretical, you should have knowledge, and practices that will make you industry ready. So with this comment, I'd like to stop. As many as 53 students have participated at the end. Earlier it was a little more than that. So with this, we will stop here if there are no questions. Right? Shall I close?
Yes, sir. So there was one student who didn't join the Google Classroom yet, sir. I have messaged you about it
You message
with
once
his
again.
email.
You message once again. I'll do it. I'll do it.
Yes.
Okay.
Yes, sir. Okay.
Okay.
Okay. Thank you, sir.
Thank you. Thank you. Right. So with this, okay, I'll end the meeting.